Hey everyone, welcome back to BigBrains chip. Today we are going to solve a very common DP problem called house robber. And rather than memorizing a DP formula, we are going to understand the decision behind it and build the solution from there. We are given a row of houses and each house contains some amount of money. Our goal is to rob the maximum amount of money possible. But there is one rule. We cannot rob two adjacent houses. So if I rob one house, I have to skip the house immediately next to it. For example, we could rob the first, third and fifth houses. That gives us 2 plus 9 plus 1, which is 12. We can't take 2 plus 7 plus 9 because we are robbing adjacent houses. So the question is, what is the maximum amount of money we can actually make? Let's not think about the entire problem at once. Start with just one house. If there is only one house containing $2, the maximum we can rob is obviously 2. Now, suppose there are two houses, 2 and 7. We can't rob both because they are next to each other. So we simply choose the larger one. The best we can do is 7. Now things get interesting when we add the third house, which contains 9. We have two choices, rob 9 or skip 9. If I skip 9, I keep the best amount I already had, which is 7. But if I rob 9, I cannot rob the previous house containing 7. So what can I combine with 9? I can go back to the houses before 7. The best amount I could make there was 2. So if I rob 9, I get 2 plus 9, which is 11. So after 3 houses, the best we can do is 11. Now notice what just happened. At every house, we have exactly 2 choices. Skip the current house, in which case we keep the previous best. Or rob the current house, in which case we add its money to the best amount we could make 2 houses before it. And we simply take whichever choice gives us more money. Let's apply exactly the same logic to the house containing 3. If we skip 3, we keep our previous best, which is 11. If we rob 3, we cannot rob 9. So we take the best amount from before 9, which is 7, and add 3. That's 7 plus 3, that equals 10. So we choose 11. Finally, we reach the house containing 1. If we skip it, we keep our previous best of 11. If we rob it, we can't rob the previous house containing 3. So we use the best amount before 3, which is 11, and add 1, and that's 12. So our final answer is 12. So we can think of our solution as simply remembering the best answer after every house. So after the first house, it's 2. After the two houses, it's 7. And after the 3, it's 11. Then 11 again, and finally 12. And this is where dynamic programming comes in. We are simply storing the best answer we have already calculated, so we don't have to calculate it again. For every house, we only need two previous answers. So the formula is just our decision written mathematically. If we skip the house, we get the previous best. If we rob it, we get the answer from two houses ago plus the money in this house. We take the maximum of those two. There's one small optimization we can make. We don't actually need to store the entire DP array. To calculate the current answer, we only need the previous two answers. So instead of keeping the whole array, we can just keep two variables. So now let's start solving the problem. We'll be having two pointers. Previous one, let it point to the index 0. Previous two, let it also point to 0. Now I'll be having a for loop for I in nums. Now we need to calculate the current max. Current value equals the maximum of, it must be either previous one or previous two plus the current value, right? So then we have to swap the values. So previous two will be equals previous one, and previous one will be equivalent to current, and at last we just need to return previous one. Let's see if this works. Yes, it does. Awesome. The main thing to remember from this problem is very simple. At every house, we either rob it or skip it. If we rob it, we use the best answer from two houses ago. If we skip it, we keep the previous place. That's the DP idea behind the house robber. And that's GYP 2. Don't memorize DSA, recognize it.